Hi, welcome back. Today we have a question which is a crane is used to lower wakes into the sea having the density of 1025 kilogram per meter cubic for an underwater project. Find the tension in the rope used by the crane due to the rectangular concrete having the density of the concrete which is 2300 kilogram per meter cubic. Block with the dimension given here 0.4, 0.4 and 0.3 meter. Okay, when it is first case suspended in the air and secondly fully immersed in the water. Okay, so the first step, we solve the first part. Alright, find the tension. Right, when the case is suspended in the air, that means there is no water or hydrostatic force involved. Okay, so once this is under equilibrium, okay, a crane is used to lower the wake. Alright, so let's say this is under equilibrium. There is no static motion of the crane, and then we consider this as we want to consider this under equilibrium state. Alright, or static. So, for this case, you can see this is concrete block, definitely gonna have the wake. And we have the force tension, the tension force going upwards. That's it. So, just apply the summation of force in y direction equal to 0. So, what the force involved? We have the Ft, which is Ft. And then, okay, the wake is pointing downward. It is negative wake. So, let's say this is pointing upward is positive and then equal to 0. You move weight to the other side and then the tension force equal to the weight of the block. Right? So, how to get the weight of the block, which is mass multiplied with gravity, where we know that the density is directly equal to mass over volume. Okay, then we can get this one replaced with rho and V. So, rho V multiply with the gravity. Okay. So, for this case, okay, it is given that, okay, what we call the density of the concrete is given, and then the gravity we know, and then the volume of this block also given. Just substitute the value. Density is 2300 multiply with the volume, which is 0.4, 0.4 and 0.3, and finally multiply with the gravity. And you will get here is 1083.02 Newton as the tension force. Okay, the next question asks, when the case of fully immersed in the water. This is the case. Alright, so when this immersed into the water, we have the wake, we have the tension force, and also we have the buoyancy force, which is acting upward to cause this block floating into the water, inside the water. Alright, for this case, okay, let's apply the equation of this case. Okay, this is case A, we solved already. We go to the case B. Again, the same, we apply the summation of force in the y direction equal to 0. We assume this to be static, there is no motion. Okay, so what do we have the force? We have the tension force, which is Ft. We have the buoyancy force, which is plus Fb. And we have the weight force, which is negative because it is pointing downward, equal to 0. So we move this, the second and the third term to the right side, and we end up equal to Ft equal to weight minus Fb. Okay, so what is the weight here? The weight of the concrete block. Okay, so the weight of the concrete block is the same with this one. Alright, just put this value 1083.02 minus with the buoyancy force. So you need to calculate the buoyancy force. Remember that the formula of buoyancy force is Fb equal to, okay, gamma of liquid displaced. Okay, this is displaced, def, displaced fluid multiply with the volume. Okay, so or gamma we expand further rho of displaced fluid G multiply with the volume. Alright, so once you consider this block immersed into the water, that means we have to consider the displace of the water. So let's say this is immersed into the water. We have the block immersed into the water. So we definitely have also the displaced water. Okay, having the same volume but different density. So for this case, we consider as the rho of fluid, displaced fluid. So just substitute here Fb equal to rho of displaced fluid, which is 1025 multiply with the gravity 9.81 and multiply with the volume, which is the volume of the same block, 0.4, 0.4 and 0.3. And then you will get your final answer to be 600.31 Newton. Okay, that is the final answer for two different cases.